Hey friends, I'm Annie. If you don't know me, I spent last 6 years as software engineer and recently focusing on AI agent. So I built this pattern kitchen. Really hope that you're having fun cooking and also learn about what is agent design pattern. So if you enjoyed this experience, don't forget to like the video or subscribe, and let's get started. Hi everyone, welcome to Pattern Kitchen. As you can see that this is a restaurant, and together we're gonna run through each of them and learn different agent design. But one honest note before we start is we're not actually cooking the real dishes here, and every chef you meet over here is just an LM agent, and every dish is whatever your pipeline produce. So the restaurant here is just a costume, and the pattern underneath and all the code here are completely real. So that's something you can learn from. Alright, so let's first get started, and we start with one single agent. It's just clicking that. With the kitchen, we have this one robot chef over here, and inside of it, it is having one model is as a brain and also a text box. So inside the text box, it has the ability of check pantry, use the stove, and plate and dish. And then we have this instruction. So you can see all the agent code over here on the right hand side. So you can see that the model, the brain is here we're using Gemini 3 Flash as a brain. And this is the instruction, and this is the toolbox. And the agent framework we're using here is Google Agent Development Kit. That is an open source free framework that you can use. So as you can see over here that we are using this single agent to handle the kitchen. And now we have one customer, one order with pasta. As you can see, we have this pasta. I mean, I love pasta. Let's see how this chef handling this pasta. So clicking next, you will see that it's actually doing this reasoning loop. The model gonna do the reasoning, you're gonna pick the tool, and then you're gonna act, and then you're gonna check the result of that tool, and it will go again. So we go through this prep, cook, plate, this react loop, and until the model think, okay, it is the right result, and gonna send out the result, and then we're gonna serve this pasta. So here we don't have any design pattern here because we are using this one single agent. And again, we are trying the salad, and it also works. Here it is another question we want to have is why we want to use agent here at all. So if we basically want to handling this agent with prep, cook, and plate, why you want to use agent at all? You can just use deterministic logic by based on the different use case. You just treat them differently. For example, on the left-hand side, this is how you can write hard-coded deterministic logic by treat each one of them individually. And on the right-hand side, basically we don't hard-code the result and rely on the agent to do the reasoning. So the reason we want to do the agent by not using deterministic logic here is with deterministic logic, you cannot write every single use case. So over here, you have all those cases already, but what if you have more cases, right? So here is why we want to use agent in this use case. But in the real life example, I really think it's worth considering using the deterministic logic, the old traditional way of coding, and if traditional programming cannot handle, you can think about using agent to do the reasoning to improve your system. So this is the single agent, but this can also considered as workflow agent. So how you add workflow is you adding all the prompt in this instruction, and you're relying on the model to do the reasoning and follow the instruction using a tool to figure out the answer. However, you know that agent is non-deterministic. So if you put all the workflow, for example, you have a very complicated workflow, and you put everything in the prompt, and you rely on this model to follow the instruction exactly, you may not always do what you want because this is non-deterministic. You're not writing deterministic code. So putting the prompt, like writing every workflow in the prompt, it can work, but it is not reliable. So how to build a reliable agent? So here, let's introducing some workflow agent from Agent Development Kit. Let's go to stage 1. So to go to stage 1, you can also go back to kitchen, and select the stage 1. So stage 1 is we want to introduce something called sequential workflow. So sequential workflow is we want to showcase how to build a workflow that's doing from A to B to C, follow this exact order, just like this assembly line. And let's take a look at this example. First, we have this pasta, we come in, and imagine right now we're still putting this workflow, the prep, cook, plate workflow, everything in the prompt. And then we are serving them as a result. However, just like what we said, this is non-deterministic. It could have the wrong order. If the order is wrong, the result might be really bad. In this example, if you do the plate first and then prep, you may get this cold ramen, and it could be a really bad result. So to solve that, we have 3 agents, and we want to put them in a sequential workflow agent so that we're adding this deterministic fixed order in this multi-agent workflow. So what does that mean? And if you take a look at the code, so again, this is ADK1 workflow agent code, and we are writing something called sequential agent, and we are putting the 3 agent in this sub-agent. So the order here matters a lot because it will for sure go from the prep to the cook to the plate. So here we are writing this, we are designing this prep agent, and then cook agent, and then plate agent. And then we're putting them in a sequential agent. So for sure, they will run from prep to cook to plate. And how they communicate to each other is through the session state. So session state is a key value dictionary. And here we have this output key equal to prep. So we're defining this dictionary. The prep is the key and the value is the agent output. And we're once the agent finish, it will pass the result to this agent. So the agent will check the result over here. And then this is the output. This is another session state with cook. So the key is a cook, the value is the result of this agent. And then it will pass to this plate agent. And the plate agent will check the result from the previous 2 agents, and then follow this instruction, and the final result is plate. So this is how to use ADK1 to pass the state to each other. So here, why we are using sequential agent, why we are not put everything in the prompt. So previously we mentioned that if you put all the sequential order in the prompt, you cannot guarantee the result. And with a sequential agent, you can guarantee that it runs from the left to right. So here we can just build the sequential workflow. We are using the benefit of agent that here we do not have to handle every single edge cases. We also have the benefit of this fixed deterministic logic that run from the left to right. So that is the benefit of it. So as you can see that we have this ramen, go to the prep stage, cook stage, and plate stage. And you can see each of them will communicate through the session state. And finally, we serve them. So this is very great that we can run them in a sequential order. However, the disadvantages of using sequential workflow is you cannot change it. For example, if you want the workflow to run differently in the single agent, you can simply just change the prompt and then you can change the workflow. However, in this workflow sequential agent, you cannot easily modify it. So the disadvantages is it's not very flexible. And this is the code that we comparing before. So here, as you can see that on the left-hand side, we have everything in the single prompt, and on the right-hand side is a sequential. All right, so we've done the sequential agent. And what's next is parallel agent. Again, go to the parallel agent. We can just go to the stage 2 directly from here. So imagine that you have 12 different dishes on this left-hand side. We have this 12 different order, and we need to go to the sequential agent one by one. So each one of them have to go to prep, go to cook, go to plate, and then go to the next dishes. And as you can see that we have 12 different dishes, so each one of them have to wait. So it will probably take very long time. Imagine each one of them, it has to take estimately 2 minutes, and 12 of them has to take overall 24 minutes. And what's more important is to cook the second dish's ramen, it may not depending on the result of the first dish's pasta. So previously, when we do the sequential workflow, one very important thing is we go from prep to cook to plate. And the input of cook is depending on the output of prepped. Similarly, the input of plate is depending on the output of cook. That means they're depending on each other. That's why it's important to do the sequential workflow. But here, imagine we have these 12 different dishes all go through the sequential workflow, that they're not depending on each other. So potentially we can do 12 dishes running the sequential workflow all together in parallel. If each dishes take roughly 2 minutes, running 12 dishes together, it takes at most 2 to 3 minutes. But if I run 12 dishes one by one, it will take adding up to like 24-ish minutes. That's a lot of time. So that's why we're introducing parallel workflow. So here is how we can potentially design a parallel workflow is we have 3 different types of agent. And one agent is handling the salad line, one agent is handling the pasta line, another is handling the ramen line. And here we are passing all of them together. And then they will go to each of the line together. And then we have this expo, the pass is to synthesize the result. So the salad line finishes first, and then it's waiting for the pasta, and then it's waiting for the ramen. And then once it synthesizes the result, like the pass, it will combine them and serve those 3 dishes together. So previously, we have the 3 dishes run one by one. It might take 6 minutes, but now it's only taking around like 2 minutes-ish based on the ramen time. And here is the code that you can take a look. So stage 1, when we have the sequential, we have the prep, cook, plate run in the sequential order. And the stage 2 is we can have the parallel agent. So here is we're using Google Agent Development Kit parallel agent workflow. And then we have each of them in the sub-agent. Once we have the sub-agent running and we have this expo agent to synthesize the result. So this is basically you can using a nested workflow. You nested the parallel and the sequential together. And that's it. You save a lot of time. This is really powerful. So here you may wonder, how do we know that the salad go to the salad line and pasta go to the pasta line and then ramen go to ramen line? So you might need something called router. So with the request, the router agent, the orchestrator agent can delegate to the corresponding sub-agent. So later on, we're going to explain what is router pattern. Here, we're using session state to communicate with different agents. And as you can see that we have all those agents, they have the output key. Basically, they have this key value pair that they will have the output to each other so that the sequential agent can, the sub-agent inside sequential agent can communicate with each other. And again, so for the parallel agent, we have this final output session state. The key is the dish. The dish is the value you pass it in. So for the salad agent, we have this key equal to salad, and the value is the result of the plate, similar to plate and ramen. So for the synthesizer expo agent, you will actually read those agents together, synthesize the result, and then finalize it. So the session state is really powerful. It's also the short-term memory in agentic system if you build with Google Agent Development Kit. And then let's go to the next stage. It's a loop agent. From last time, we have this salad line, pasta line, and ramen line. But you do not have anything to criticize the result. What if you have this cold ramen that's being served? And that's not going to be good, right? So we have this pasta, and then we are serving this cold pasta. It's not meeting our standard. So how to have quality result, how to making sure our agentic system having the result that meet our requirements. So one way to solve them is to have a loop and critique pattern. Basically, we want to keep cooking until it's meeting the criteria. And if it's meeting the requirement, it will serve it. If it's not meeting the requirement, it will keep cooking until it's meeting the requirement. And in case we run into the infinite loop, we also set the maximum iteration number so that it won't run out of the loop. And here we are setting the maximum iteration equal to 3. So let's give it a try. And first, we are cooking this ramen, and then the the critic think, okay, let me taste this dish. Oh, okay, I'll give this 1 star. Because it's not meeting the standard, it will go back to the cook agent, and cook agent will read the result of the critique and realize that, okay, I haven't met the requirement, let me cook this again. So once they try to recook it, the critic agent will try to taste these dishes again, and it will give it a new result. So now we have 2 star, 2 hurt. And then the cook agent realized, okay, I still haven't met the result. Let me cook this again. And finally, the critic agent tasted and said, okay, now it's 3 hurt. It's meeting the requirement. Now let's serve them. So what you're just seeing is we are having this loop agent, we are having this critic agent, and critic agent will having this critique state, and then so it's determining whether we need to continue the loop or break the loop. We also have the maximum iteration equal to 3, so that even though you're not meeting the requirement, but if the max number is 3, it will also serve it. And here, so the cook agent is trying to cook the dish, and the critic agent will take this dish and trying to rate it. So we're trying to have this result as this critique as the output value. And this critic agent will also have a tool called pass dish. So pass dish is once it's meeting this standard, it will call the pass dish and set this value to be true. If it's not meeting the requirement, it will continue to fix it. So in the sequential agent, you will run the taste loop first, and then you will run the serve, so that whatever the result we have from this cook and critique loop agent, we will serve them. And here, this is a nested of sequential and loop agent. You can also see that without the gates on the left-hand side, we just have the cook and serve. So whatever you cook will be served. And on the right-hand side is we have this taste loop, and to ensure we are meeting our standard. So now we cover the sequential, the parallel, the loop, and next is the routing pattern. Imagine that we have this kitchen agent and we have this different type of inputs. So at the door, we have this input like, I want to order this ramen. I also have an input which is a complaint about it's too slow. Again, I have another request, that is I want to book a reservation on weekend morning. So I have 3 types of requests, and they all go to this kitchen agent. Remember, the kitchen agent can only prep and cook and plate the food. So it cannot handle the complaint request or the reservation request. Also, the kitchen cannot help with the reservation. So what we can do is we're trying to have the host agent. The host agent is like a router. And then we have the 3 sub-agent. They are the kitchen, the manager, and ledger. So kitchen agent only responsible for cooking and plate the food. The manager agent is to help with the complaints. And the ledger is help with the reservation. So again, like we have this ramen here, and the host will delegate to the kitchen agent, and then we have this reservation, and the host, this router agent, will delegate to the ledger agent, and we have this complaint, the router agent will delegate to this manager, human agent. And that way, we can just managing the process. So here we have this human in the loop to handling these complaints. And if you take a look at the code, this is the deterministic router. So in the deterministic router, we will have this deterministic logic on how to delegate to the sub-agent. I would say in the deterministic logic, it is not a sub-agent, it is delegated to the corresponding agent. So we are making sure that we are mapping each kind, and then based on the kind, we will have this mapping to the agent. So here we are guaranteed we are mapping to the corresponding agent. But again, the logic is handling the limited condition. And in this example, we are using the LLM agent. So LLM agent, basically we are putting the routing logic in the instruction. In the instruction, we're basically saying how we want to delegate to the sub-agent. And in the sub-agent, we're putting the agent that we want to delegate to. In this case, we have kitchen, reservation, and the manager. And here is the logic on how we want to delegate to the sub-agent. So both ways can do routing. So with a deterministic logic, you can, if you want to have some temperature, So with deterministic router, for example, you want to have exact check. Like if you want to check if the temperature is larger than certain degree or lower than certain degree, go for a different agent. Deterministic router is a great use case. However, if it is hard to check all the different conditions, using the parent-child agent delegation is also an easy way to delegate to the corresponding agent. But again, this is more flexible but less control because you cannot guarantee how it's delegating. With the deterministic logic, it's guaranteed to delegate to a certain agent, but it is not very flexible. It is your choice on when you're using this router pattern and which way is best for you to design this router logic. Alright, I think that is for the router pattern. So now we're understanding the routing pattern. The last we want to look at is the graph workflow. Like what if your pattern is more than simple sequential or parallel or critic and loop? What if it's more complicated graph? And here, as you can see, that we have all the relationship together with the edges and node here. So the node corresponding to either the router or the parallel agent or the loop agent or more. And then the edge is the relationship between them. So let's take a look. Stage one is we have this assembly line. We have this pass star to expo, to critique, to serve this assembly line. We can using sequential agent. And the second is we have those parallel agent. So for a different type of request, you can go to the salad line or pasta line or ramen line, and then the expo is to synthesize the result. And then we can have this critique, loop and critique agent that we could keep cooking the pasta until it's meeting the requirement of critique agent. You can also have this condition gate, like we have this router, and based on the condition, it will delegate to manager and ledger agent. So putting them together is like a potential workflow of overall restaurant system. And with ADK1, you can potentially using a nested of different workflow agent, like sequential agent, loop agent, parallel agent, and more. But with ADK2, we have something called graph workflow, so that you can directly map in this pre-existing graph and writing this graph edge and node to control this whole workflow. So here is potentially way of you can do it. On the left is how you can use ADK1 with the existing workflow agent, but you can have to keep resting the nested of workflow agent to handling the overall flow. And on the right hand side is you can just directly custom the edge and node, and so that you can just creating this graph and handling all the workflow. However, this is only for pre-existing graph. What if you have a request that you do not know the workflow yet? So here we might need to introduce something called dynamic workflow, which we can introduce in future episode. And that's it for this pattern kitchen. So for now, we covered the sequential, parallel, loop, routing pattern, and collaborative graph workflow. I hope that you're having fun and learn a lot with the different agent pattern. And if you like it, don't forget to subscribe, and I will see you in the future episode. Bye!